Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. So today I'm going to continue our lesson today. That is chapter 3, chemical bonding. Okay, from our previous lecture, you learned on Lewis electron dot structure. That is Lewis structure. So we know that Lewis structure consists of the chemical symbol of an element. So there is at the center of the Lewis structure, there is a chemical symbol of an element, and then surrounded by dots that representing the valence electron in an atom of the element. So it's surrounded with the valence electron. For example, carbon. So we know that carbon in group 14. So carbon at the center, C at the center, and then it's surrounded with the 4 electron valence. Okay, because it's in group 14. So group 14, so it have 4 electron valence. Or another example is sodium, Na. So we know that Na is in group 1. So it have 1 electron valence. So that's why we have only 1 dot. And then oxygen. So oxygen in group 16. Okay, in group 16 or group 6A. So it have 6 electron valence. So that's why this O is surrounded with 6 dot, because this dot is representing the valence electron. Okay, this is the Lewis dot structure for ion. Okay, for ion. So for ion, we write the Lewis structure using the square bracket. Okay, so for example, Na it lost 1 electron valence, so that's why it formed Na positive, because it lost 1 electron, so there is no dot surround with Na. So we just write the square bracket Na with the square bracket, because there is no electron inside surround with the Na. And then chlorine. So chlorine, we know that chlorine has 7 electron valence because it is group 17. So it have 7 electron valence. So when it gain, when chlorine gain 1 electron from outside, so it will become Cl minus. So that's why there is an extra electron here. So it is become 8 electron. So this 8 electron, then you need to write the square bracket and then put right negative. And then this is for the polyatomic ion. Okay, inside this one is a ion. Okay, there is a square bracket. And then outside the square bracket, there is a negative one. So we know that Lewis structure is depends on the group of the element. For example, group 1, it have 1 dot. It have 1 electron valence. Group 2, it have 2 electron valence. Group 3 or 13, it have 3 electron valence. Group 4A or 14, it have 4 electron valence. 5 or 15, 5 electron valence. 6 or 16, 6 electron valence. 7 or 17, it have 7 electron valence. And group 18, so it have 8 electron valence except helium. Okay. Okay, then we learn about the chemical bonding. There is ionic bonding, covalent bonding, dative covalent bonding, and metallic bonding. Okay, this is the formation of ionic bonding. Okay, you learn on this one how to write the Lewis dot structure for the formation of ionic compound. So there is a transfer of electron from Na to the Cl. Okay, so from Na to the Cl. So Na, because it have 1 electron valence, then Cl it have 7 electron valence. So there is a transfer of 1 electron, transfer of electron. So it will become Na plus, because this Na is lost 1 electron, so it become Na plus. And then for the Cl, it have 7 electron valence because it gain electron from the Na. So we just write 8 electron outside, surround with the chlorine, and then in square bracket and put negative value. Okay, put negative. So this is the Lewis dot structure for the formation of ionic compound. Okay, now we go to the formation of the covalent compound. So when we compare to the ionic compound, this covalent compound is a sharing of electron. Okay, ionic compound is about the transfer of electron. It's totally different between the ionic and covalent compound, because covalent compound, it talks about the sharing of electrons. So it means that one atom will share their electron with another atom. Another atom will share their electron. Both are sharing a electron. So for example, here, show the formation of F2 compound of using Lewis dot structure. Okay, for example, this fluorine, it have an electron, then it share with another fluorine, the electron from the another fluorine. So it will become the sharing of electron, something like this. So it will form octet. So electron pair shared between the two fluorine atoms. So from here you can see that there is a sharing of electron for the fluorine. So this fluorine will share one electron, and this fluorine also share one electron. So it will become octet. So when sharing the electron, we call it as covalent compound or covalent bonding. Okay, this is another type of covalent bonding, that is dative covalent bonding. Because in this dative covalent bonding, it's still a covalent bonding. Okay, it is a covalent bonding. But both electron come from the same atom. Dua-dua elektron datang daripada atom yang sama. For example, this one NH3 and HCl. So, this nitrogen will give their 2 electron to the hydrogen. Both our electron comes from the nitrogen. So it will form a sharing of electron, but sharing from the nitrogen only. So this nitrogen will share with the hydrogen. So both of these binding electron is come from the nitrogen atom. It's not come from the hydrogen. Okay. So this is the dative covalent bonding. Okay, previous lecture we also learned on the how to draw the Lewis structure. Okay, this is the step to draw the Lewis structure. We have 3 steps. Okay, for example here, if we want to draw the structure of ammonia, so first step you need to calculate the valence electron for the element. Electron valence for elements in ammonia. For example, valence electron for nitrogen, and then you add with valence electron with hydrogen. So 5 plus 1 plus 1 plus 1. So you will get 8 electron valence for this molecule. Okay, electron valence only, not the core electron. And then for step 2, okay, you need to arrange the atom. Symmetry. Okay, symmetry. Try to arrange the atom symmetry. And then the central atom, it should be more electropositive element. More electropositive atom. Okay, for example, NH3, nitrogen is the more electropositive atom. No, not nitrogen. Hydrogen is more electropositive. But because of the hydrogen cannot be a central atom, so we put nitrogen at the center. Again, so nitrogen at the center because H cannot be at the center atom. So you just arrange N at the center, and then around the nitrogen is hydrogen. And then at step 3, you need to calculate the number of non-bonding electron. Okay, so 8 electron minus 6 electron, that is bonding electron, you will get 2 non-bonding electron. And these 2 non-bonding electron you can put at the center of the central atom. Okay, for the nitrogen, because we know that nitrogen should have 5 electron. So that's why it can get 5 electron for the nitrogen. So it will become octet. Okay, in our previous lecture, we also learned on the molecular shape. Okay, so all here are molecular shape. It depends on the bonding electron and bonding electron. From here, for example, if we have a bonding electron 2 bonding electron, okay, so for example, BCl2, so linear. BF3, trigonal planar. CH4 or NH4 plus tetrahedral. PCl5, trigonal bipyramidal. SF6 is octahedral. All here are molecular shape. Okay, but for this molecular shape, there is no electron pair at the central atom. So you need to remember all these molecular shape. Okay. So this is the molecular shape when we have the electron pair at the central atom. For example, SO2. So SO2, there is a 2 surrounded atom, but we have 1 electron pair. Okay, so we call it S band. And then here we have 1 electron pair and 3 surrounded atom, trigonal pyramidal. 2 electron pair and 2 bonded electron, band. 4 bonding pair and 1 electron pair. We call it as distorted tetrahedron. And then I have 3 bonding pair and 2 lone pair, T-shape. When I have 2 surrounded atom and 3 lone pair, linear. And then 5 bonding pair and 1 lone pair is square pyramidal. And if I have 4 bonding pair and 2 lone pair is square planar. Okay, so you need to remember all these molecular shape, all this structure. Okay, this is our new subtopic, that is dipole moment and bond polarity. So we focus now on dipole moments and bond polarity. Okay, this is the dipole moment. Okay, so we represent dipole moment is something like this. Okay, for example, hydrogen, not hydrogen, HF, hydrofluoric acid. So from here you can see that there is a region where there is a electron rich region, and there is a region where electron poor region. Ni sikit elektron, and this one is banyak elektron. Kan kita tahu, we know that fluorine it have 7 electron valence, right? 7 electron valence. So it have a rich electron valence. So that's why the region is bigger as compared to the electron poor region. Contoh hydrogen. Hydrogen kan dia hanya ada satu electron valence. Dia sedikit electron valence. So bila dia sedikit, region dia kecil as compared to the electron rich region. So kalau kita buat, when we draw the structure, so we can see that the region for the ni contoh ni structure ni kan. Kalau kita tengok dia punya region dia, fluorine ni besar. Fluorine ni besar, hidrogen ni kecil. Sebab apa? Sebab kawasan ni banyak elektron. Kawasan ni sedikit elektron. Okay, so bila dia ada berlaku sebegini, we call it as dipole moment. There is a dipole moment, and this molecule we call it as polar molecule. Kalau ada region-region yang satu besar satu kecil, kita panggil dia molekul tu polar, ataupun dia ada dipole moment. Okay. Okay, now we go to the polarity of the molecule. So molecule, actually it can be divided into two types. That is polar molecule and non-polar molecule. So there is a difference between the polar molecule and non-polar molecule. So for polar molecule, okay, I give an example for polar molecule, that is HF. Okay, contoh yang tadi lah. So HF. So this HF is a polar molecule. So for polar molecule, it should be diatomic molecule. So it will have a 2 atom. Kena ada 2 atom lah, diatomic. So it means that we have 2 atoms. So this molecule have 2 atoms. And it should be composed by different atom. Kena dua-dua atom tu atom yang berbeza. For example, this HF. So it have a different atom. And it should have a dipole moment. Apa itu dipole moment? Dipole moment, maksudnya dia ada region lah. So it means that if there is a electron rich region, so it's bigger as compared to the electron poor region. Ni region tu besar, satu lagi kecil. Sebab apa dia besar? Sebab dia banyak elektron. Sebab apa dia kecil? Sebab dia sedikit elektron. So dia ada region dia yang menyebabkan dia sangat besar. Dekat kawasan tu besar. So bila kita nampak dia satu besar, kita boleh buat dipole moment. Dipole moment tu adalah kita buat satu arrow. Arrow dia seperti ini. So this arrow is, we call it as dipole moment. Okay, arrow dia mesti arrow menghala ke electron rich region. That is fluorine. So we know that fluorine is electron rich region, right? So arrow it should be to the fluorine. So arah dia mesti ada arah ke sana lah. And then letak palang kat hidrogen tu. So maksudnya dia memang daripada hidrogen sampai fluorine je. Jangan kalau kita tak letak palang tu, maksudnya ada benda lain lah kat tepi kan. Tak nak kita, so kita letak palang. So it means that kita start memang daripada hydrogen to the fluorine. Okay, and then you need to draw the dipole moment, the symbol for the dipole moment. The symbol of dipole moment is like this. Tanda dia mesti macam S tau. S dia, dia punya tail dia mesti sampai sini je. And then put positive. So this is dipole moment. And then for fluorine, okay, dia ada S sampai hujung tu, and then negative. Okay, tengok previous slide. Tanda dia seperti itu. So it show that there is a dipole moment. Okay, so this is the polar molecule. And then for non-polar molecule, okay, non-polar molecule, again an example there is, for example, CH4. Okay, so this CH4 is a non-polar molecule. Okay, non-polar molecule. So non-polar molecule, it should be diatomic atoms. Diatomic molecule. Dia boleh juga molekul lain sebenarnya. Tapi Kalau kita kata diatomic boleh lah. Diatomic tak ada masalah. Diatomic molecule and other atoms, okay, other molecules, but it must be at the same element. At the same element. For example, CH4. CH4 it have the same element. It depends on the polarity of the bond and it depends on the shape of the molecule. It depends on the shape of the molecule. Kalau the shape, the symmetry, kita kata dia non-polar molecule. Dia mesti kalau shape dia simetri. Contoh kalau shape dia HF ni dia tak simetri kan, sebab dia adalah dia mempunyai atom yang berbeza. Tapi kalau non polar molekul dia bergantung kepada polarity. Polarity ni bergantung pada sama ada dia boleh cancel ataupun tak, ataupun dia bergantung kepada bentuk dia. Nanti saya akan terangkan, kita akan tengok contoh-contoh dia. Okay, I give an example, that is carbon dioxide. Okay, so from here, this is the structure of the carbon dioxide. C at the center, and then oxygen. The surrounded atom is oxygen, and it is a double bond. Kalau kita lebih structure lah, dia macam ni lah. C at the center, and then surrounded atom is oxygen. Okay. Bond dipole and dipole moments are vector quantitative, have a magnitude and vector. Actually, it have a bond dipole. Dia mesti ada bond dipole, that is from more electropositive to more electronegative. So kalau tengok region dia seperti ini. Ada kawasan yang electron rich region. Of course, oxygen is electron rich region. Ni electron rich region. Okay, ni electron-rich region. Ni besar dia sikit. Kawasan oksigen ni besar. Kawasan karbon ni kecil. Dan kawasan oksigen ni besar. Sama besar dengan oksigen ni. So, there is a electron-rich region and at the center, electron-poor region. Electron-rich region and electron-poor region. So, there is a dipole moment for carbon to oksigen. So, buat arrow seperti ini, Okay, arrow seperti ini. So, start from carbon to oxygen. And then, start from carbon here to the oxygen here. Ni buruk sikit lah lukisan saya ni. Okay. And then, from carbon, it should be positive. And from oxygen is negative. Sama lah tadi. Super je lah kan. Okay. So, it have a dipole moment. For Cr2, it have a dipole moment. But, when you add individual bond dipoles, one can determine the overall dipole molecule. You can add. And then, if you add this dipole moment, it will cancel out. Dia boleh cancel. Dia boleh jadi overall dipole moment, dia akan jadi zero. Kan cancel lah. Kita tambahkan tu, dia akan jadi overall dipole moment tu kosong. So, kalau lah overall dipole moment is equal to zero, we call it as a non-polar molecule, not a polar molecule. Because walaupun dia ada dipole moment, is still non-polar because of the symmetry of the molecule, because it can cancel the dipole moment. So contohnya, kalau lah dia boleh cancel dipole moment tu, dia boleh kosongkan dipole moment tu, kita kata dia non-polar molecule, bukanlah polar molecule. Seperti itu. Okay, this is another example, okay, for dipole moment, that is H2O. Okay, so this is the structure for the H2O. O at the center, and then we have the hydrogen as a surrounded atom. Okay, and then the structure is band structure. Kalau tengok structure pun tak simetri. And then ada kawasan oxygen is electron rich region, and then hydrogen is electron poor region. Seperti inilah kalau kita tengok electron region dia seperti ini. Kawasan elektron kawasan yang ada elektron tu. Okay, so two OH bond are identical and the bond dipoles are equal in magnitude. So, kita tengoklah bond dipole adalah daripada hydrogen to oxygen. Hydrogen to oxygen. So, when we add this dipole moment with this dipole moment, kita akan dapat overall dipole moment ke atas. Kita tambahkan dia. Kita dapat overall dipole moment ke atas. So, bila kita dapat overall dipole moment ke atas, kita kata dia polar. Sebab dia tak simetri pun. Dan kita dapat overall dipole moment. Kita tak dapat pun equal to zero. So, the bond dipoles do not directly oppose each other and therefore do not cancel each other. So, when we cannot cancel each other, when we cannot cancel the dipole moment, this molecule is a polar molecule. Itu syarat dia. Dia kena, kalau nak jadi dia non-polar, dia kena simetri. So, bila dia simetri, dia boleh cancel. Dipole moment dia boleh cancel. Tapi kalau polar molecule ni, kalau lah molecule tu tak simetri, Dia tak boleh cancel. Dipole moment tu tak boleh cancel. Okay. Okay, this is another example in ammonia, NH3. Okay, ammonia, NH3. So, we have 3 bond of the NH3 are identical. Okay, NH are identical. So, we have 3 bond NH are identical. And the structure is trigonal pyramidal. Trigonal pyramidal. Okay, when we draw the dipole moment, you can see that from the hydrogen to the nitrogen. This is the dipole moment. And then if you add the dipole moment, the overall dipole moment, it is upward. Dia ke atas, upward. Okay, upward. So there is a dipole moment. There is a dipole, overall dipole moment. It cannot cancel each other. The dipole moment cannot be cancel each other. So when dipole moment it cannot be cancelled, cannot cancel each other, and because of the structure is non-symmetry. So this is, we call it as polar molecule. So nampaklah dia tak symmetry pun. Ni polar molecule. Okay, there is a few example here. Again, determine which molecule is polar and show the direction of bond dipoles if any. Ni soalan yang biasa keluar lah. Dia tanya, mana satu molekul polar? Lepas tu kena tunjuk dia punya bond dipoles tu, kalau ada. Okay, first we go to CF4. CF4. So, this CF4 is a tetrahedral structure. Okay, hala dia semua hala ke atas lah, from the carbon to fluorine. Carbon to fluorine. Kenapa? Sebab fluorine ni electron rich region. So, hala dia hala ke fluorine. Semua hala ke fluorine. So, kalau kita tambahkan dia semua, so, and then the symmetry pula tu, dia mesti boleh cancel. The dipole moment can cancel each other. So, bila dia can cancel, dia is equal to 0. So, the structure is non-polar. Okay. BF3. BF3 pun sama, the dipole moment start from the boron to fluorine. Boron to fluorine. And then because this structure is symmetry, and if you add the dipole moment, you will get overall dipole moment is equal to 0. So, BF3 is a non-polar. And then CH3Cl. CH3Cl. So, Cl. Ada pula Cl kat sini. Kalau CH4, dia simetri. Ada pula Cl. Cl tak simetri. Okay. So, dia punya dipole moment dia from carbon to chlorine. Carbon to chlorine kan. So, structure tu adalah polar. Okay. And then SH2. Structure dia band. Kalau band, daripada hydrogen to sulfur. Kalau kamu tambah dua-dua ni, dia overall dipole moment hala ke atas. So, cuma 3 lagi, tak boleh cancel lagi. So, kita kata dia structure tu adalah, molekul tu adalah polar molecule. Okay, this is another example, COS. Okay, carbon, oxygen and sulfur. Tengok dua-dua dekat ni, surrounded atom dia, dua-dua dia lah atom yang berbeza. Okay, from carbon to oxygen, carbon to sulfur. Tapi sebab oxygen ni lagi besar region dia, sebab oxygen ni lagi banyak elektron berbanding sulfur. So, bila dia banyak elektron, region dia lagi besar. So, dipole moment dia menghala ke oksigen. So, polar molecule. Walaupun bentuk dia macam macam linear kan. Sepatutnya linear, sepatutnya non-polar. Tapi disebabkan dua-dua atom ni berbeza. Dua-dua atom ni berbeza. Bila dua-dua atom berbeza, oksigen ni lebih besar sebab dia electron rich region. Dia banyak elektron berbanding sulfur. So that's why the overall dipole moment menghala ke kiri. So it is polar molecule. Now we go to the CH2Cl2. Kalau tengok dia ni tak simetri jugalah sebab ada dua yang berbeza, dua atom berbeza, dua atom hidrogen. Dia tak simetri kalau potong tengah-tengah dia pun dia tak akan dapat simetri lah. So dipole moment dia dari carbon ke chlorine. So dia menghala ke sana pula. Dipole moment dia kan. Overall dipole moment. So this structure is a polar. Okay, now we go to the noble gases. We know that the noble gases is in group 18. So the noble gases have complete outer energy level. it have a complete electron valence. There is 8 electron valence. So it cannot give or it cannot get or give any electron. Dia tak boleh dapat elektron, dia tak boleh bagi elektron sebab dia dah octet. Sebab dia dah octet kan. Kalau dia tak cukup elektron, dia boleh terima. Kalau dia ada macam ada satu elektron, dia boleh bagi kat orang lain kan, bagi kat atom lain. Tapi because of this noble gases, it have complete octet, it cannot get or give its electron. It cannot get or give any electrons. So the noble gases are not reactive. So it do not form bond because it cannot get or give the electrons, its electron valence. Sebab electron valence tu lah yang membentuk ikatan. So kalau dia tak boleh bagi, dia tak boleh nak share, so dia tak reactive for the noble gases. So this is the stability of noble gases. So noble gas atom has an octet of 8 electron in its valence shell. Thus, noble gas are inert because it have an 8 electron. So it is inert. It do not take part in any chemical reaction. Dia tak boleh mengambil tindak balas dengan mana-mana tindak balas. In a chemical reaction, an atom achieve an octet or noble gas configuration by transferring its valence electron or sharing a pair of electron. So, untuk atom lain selain noble gases, dia mesti cuba untuk mencapai satu keadaan noble gas configuration that is cukup 8 elektron. Contohnya sodium. Sodium kan ada satu elektron valence kat luar kan. Dia nak dapatkan octet dia dapatkan core elektron yang dalam dia saja, dia kena buang satu elektron. Ataupun chlorine. Chlorine it have a 7 electron valence. So to become octet, it should accept 1 electron valence from the other atom. So atom ni dia akan cuba capai octet ataupun noble gas configuration by transferring its electron valence or sharing a pair of valence electron. Okay, now we go to the octet rule and its exception. So there is a exception for the octet rule. Maksudnya tak semestinya 8 elektron. Tapi adalah a few molekul yang tak semestinya ada 8 elektron. Kita tengok sekejap lagi. Octet rule. Octet rule state that the atom tend to gain or lose electron until they have 8 electron in their valence shell to form stable compound. Okay. So maksudnya atom ni dia cuba akan buang elektron dia ataupun dia terima elektron dia asalkan dia cukup 8 elektron. Okay. Sebab cukup 8 elektron dia lebih stabil. Contohnya klorin tadilah. Klorin kan 7 elektron valence. So dia nak cuba dapatkan octet, dia mesti terima 1 elektron valence. Tu syarat dia. An octet configuration, an octet correspond to an electron configuration ending with S2P6. So maksudnya masih S2P6 sebab cukup 8 elektron. Contohnya neon lah. Neon kan dia stable. So dia pada keadaan 8 elektron. S2 to S2 to P6. Okay. Okay, this is the exception to the octet rule. There is a 3 exception for the octet rule. Odd number of electron, less than an octet, more than 8 valence electron. This one we call it as an expanded octet. Ada 3 exception. Odd number of electron. Though relatively rare and usually quite unstable and reactive, there are ions and molecules with an odd number of electron. Okay, walaupun dia tak stabil, tak reaktif, tapi memang ada molekul yang ada odd number of electron. Dia tak berpasangan. Ada pula ni kawasan dia tak berpasangan. For example, in a freeze condition, NO, okay, nitrogen monoxide, will form dimer to produce N2O2. In this structure, the nitrogen is already get an octet configuration. For example, NO. So from here, you can see that this NO, okay, it is a odd electron, odd number of electron. So kalau tengok 1, 2, 3, 4, 5. Nitrogen kan kena 5 kan. Dia boleh pula form 1 kat sini. Oksigen ni 6. 1, 2, 3, 4, 5, 6. So kalau kita tengok total dia 1, 2, 3, 4, 5, 6, 7. Kalau kita tengok dia tak bentuk 8 pun. Tak bentuk 8 pun. So we call it, this one is odd number of electron. Okay. Ataupun dia boleh juga membentuk seperti ini. 1, 2, 3, 4, 5, 6. Atau 1, 2, 3, 4, 5. So oksigen pula tak cukup 1. So this is we call it as odd number of electron. Okay, now we go to BF3. BF3. So when we draw the structure of BF3, actually it's very difficult because for example, we try to draw the structure BF3. Cubalah buat structure BF3 ada seperti ini, seperti ini, seperti ini. Okay, so give boron a field of octet places a negative charge on the boron and positive charge on the fluorine. Cubalah buat supaya ni fluorine ni 2, 4, 6, 7. 2, 4, 5, 6. 2, 4, 6. So, kalau kita kira dia punya formal charge, kita dapat positive 1, negative 1, 0, 0. Seperti itu. So, bila kita dapat seperti ini, kan saya kata formal charge should be at 0, kan? So, dia tak stable actually. Dia tak stable. So, this one is this three law structure is not accurate. Okay, this would be not accurate picture for the distribution of electron in PF3. Okay, ni salah lah. Cara yang dia salah. Therefore, structure that put a double bond are much less important. So, dia tak penting. Dia kurang penting. So, if filling the octet of the central atom result in a negative charge on the central atom and the positive charge on the more electronegative outer atom, don't fill the octet at the central atom. So, it will become this one is most important as compared to this one, it's less important. Okay, I go to the last exception to the octet rule. There is a more than valence electron. That is, we call it as expanded octet. Yang tadi tu kalau tengok BF3 tu, dia tak cukup elektron kat boron kan? Boron tu ada 6 elektron sahaja. Tapi kalau kita tengok yang more than 8 valence electron ni, ada pula molekul yang dekat tengah dia, dekat central atom, dia ada lebih 8 elektron. Okay. It's only applicable to elements in third row or below. That is period 3 and below. How? Because use their MTD orbital to accommodate additional electron. So the larger the central atom, the larger the number of atoms that can surround it. Okay, this one for third row or below. Untuk period 3 dan ke bawah. Sebab apa? Dia ada MTD orbital. Because of the empty d orbital. Kalau yang bawah-bawah tu, yang atas-atas dah ada d orbital dah ada berisi. Yang kat period 1, period 2 and 3, because there is a empty d orbital. Okay, this is example for the expanded octet. Okay, for example, this PCl5. Okay, PCl5 after it share with the chlorine. Okay, we know that chlorine is 7 electron. Semua setuju lah kan? Okay, chlorine dia bagi 1 elektron, and then phosphorus pun bagi 1 elektron. So, kalau kita tengok phosphorus dia bagi 5 elektron dia. And then after sharing with the chlorine, kita nampak lah. Kita totalkan untuk phosphorus punya elektron, kita dapat 10. 2, 4, 6, 8, 10. 10 elektron. Phosphorus tu dah lebih pula elektron. Kita panggil dia expanded octet. Tapi walaupun dia ada 10 elektron, kita kata PCl5 is a stable compound. Okay, stable compound. Ni contohlah expanded octet. Ataupun SF6. SF6. Okay, sulfur ni pun sepatutnya 5 electron valence. Tapi after dia share dengan fluorine ni, dia share dengan fluorine. So, kalau kita tengok total dia, ada 10 juga. 10 elektron. Okay. So, sulfur ni, SF6 pun adalah expanded octet. Another example is PO4. PO4. PO4 3-. Okay, phosphate. Phosphate ion. Okay, for this phosphate PO4 3-. Okay, the correct structure is this one. Kalau tengok kan, kalau kita tengok yang first structure tu, dia ada 1, 2, 3, 4. Ada 4 line kan. So, ada 8 elektron. Okay, setiap ni ada 2, 4, 6, 8. 8 elektron. Tapi dia sepatutnya stabil kan. Sepatutnya dia stabil lah sebab dia 8 elektron octet configuration. Tapi kalau kita kira formal charge, dia dapat positif, negative 1, negative 1, negative 1, negative 1. Tapi kalau kita buat satu lagi structure, okay, this structure, second structure, this one. So, if you calculate the octet for the phosphorus, kita dapat 2, 4, 6, 8, 10. Lebih pula lah elektron. So, dia ada 10 elektron. The expanded octet. Tapi, if you calculate the formal charge, you will get 0, 0 at the center. So, from here, you can see that this structure is more stable. Walaupun dia expanded octet, dia tetap lebih stabil. Okay? Okay, this is the expanded octet. Okay, this is the last subtopic, our last subtopic for this chapter, that is intermolecular forces. Okay, actually there is two types of forces. There is intermolecular forces and intramolecular forces. So there is a difference between these inter and intramolecular forces. So the difference is intermolecular forces. Okay, intermolecular forces, it exists between the molecules and influence the physical properties of the substance. Okay, it exists between the molecules. Dia wujud antara molekul. For example, saya ada molekul oksigen, water. So this molecule of water. Okay, this molecule of water. And then saya ada molekul of water satu lagi sebelah dia. Okay, okay, antara dalam molekul water ni, okay, yang kat sini ni, kita tak kata dia intermolecular forces. Yang intermolecular forces dekat mana? Dekat sini. Ni, this one. Antara oksigen dengan hidrogen. Antara oksigen molekul satu dengan hidrogen molekul kedua tu, ni kita panggil dia intermolecular forces. So, maksudnya, dia wujud antara molekul, antara dua molekul. Okay, for example, hydrogen bond and London dispersion bond. London dispersion forces. Satu lagi, dipole-dipole forces. Okay, but this intermolecular forces is weaker forces as compared to the intramolecular forces. Forces yang dekat dalam molekul sebenarnya lagi kuat berbanding forces di luar molekul. Forces antara molekul. Okay, another type of forces is intramolecular forces. So it exists within the molecule and influence the chemical properties of the substance. Dia wujud dalam molekul. Okay, so yang kita belajar sebelum ini, that is ionic bonding, covalent bonding is the intramolecular forces. So maksudnya forces yang dekat dalam water ni, ni water molecule kan, so dekat dalam ni kita panggil dia intramolecular forces. So this intramolecular forces is a stronger forces as compared to the intermolecular forces. Okay, I give an example here. Okay, intermolecular forces and intramolecular forces. So intermolecular forces, okay, it exists between the molecules. Okay, so intermolecular forces exists between molecules. For example, I have two water molecule here. Okay, so there is a forces between oxygen and hydrogen. Wujud forces tu antara oksigen yang molekul satu dengan hidrogen molekul satu lagi. Antara oksigen dengan oksigen tak wujud forces tu. Sebab negatif dengan negatif kan? Negatif-negatif ni menolak. Tak suka. Tapi kalau negatif oksigen ni dengan hidrogen ni, dia ada forces. Dia ada macam ada tarikan. Negatif dengan positif kan? Macam tu lah. Okay. Contoh kita dah couple dengan seorang tu, walaupun ada orang lain, macam ada tarikan sikit dengan orang lain tu kan. So macam tu jugalah. So walaupun dia dah couple tapi tetap ada tarikan sikit dengan orang lain. So this one we call it as intermolecular forces. Okay, for example, hydrogen bond, London dispersion force or dipole-dipole forces. But this forces is weaker forces as compared to the intramolecular forces. But for the intramolecular forces, it exists in molecule, inside the molecule, within the molecule. For example, the ionic and covalent bonding. And this is as intramolecular forces can influence the chemical properties of the substances. So this is the intramolecular forces. This is a hydrogen bonding. Bukan hydrogen, covalent bonding. So this covalent bonding is intramolecular forces. So when you compare the energy for the inter and intramolecular forces, so for intermolecular forces antara molekul ni 41 kJ to vaporize 1 mole of water. So tenaga dia kecil sahaja untuk vaporize. Tapi kalau kita nak pecahkan bond dekat dalam intramolecular forces, we need about 930 kJ to break all the oxygen hydrogen bond. Kita nak pecahkan ikatan oxygen hydrogen bond ni dalam 1 mol air. So it means that intramolecular forces have more stronger as compared to the intermolecular forces. Okay, so for intramolecular forces dah belajar tadi. Ionic bonding, covalent bonding dah belajar tadi. Now we focus on intermolecular forces. Kita nak tengok pula forces antara molekul. Okay, lepas ni. Okay, this is type of intermolecular forces. Antara molekul Sekarang ni kita cakap bukan dalam molekul dah. Kita cakap antara molekul. So, we have two types of intermolecular forces. That is London dispersion forces, hydrogen bonding, and dipole-dipole forces. But when we compare these three types of forces, hydrogen bonding is much more stronger as compared to the dipole-dipole forces. Dipole-dipole forces at the center. So when we compare to hydrogen bonding dengan dipole-dipole forces, of course hydrogen bond is more stronger as compared to the dipole-dipole forces. But when you compare between the dipole-dipole forces and London dispersion forces, London dispersion forces are much more weaker as compared to dipole-dipole forces and hydrogen bonding. So kalau kita tengok kekuatan dia, kita susun seperti ini. Hydrogen bonding lebih kuat, tengah dia dipole-dipole forces, yang paling lemah kita kata London dispersion forces. Now we go to the London dispersion forces. Okay, so the London dispersion force is a temporary attractive force that result when the electron in two adjacent atoms occupy position that make the atom form temporary dipoles. So, it between non-polar molecules. Okay, so London dispersion forces ni antara non-polar molecule. Dia adalah temporary attractive force. Dia jumpa je atom lain, dia ada tarik-tarikan. For example, interaction between the hydrogen gas, chlorine gas, and CH4. Okay. For example, here chlorine gas here. So the red dot here is a intermolecular forces, the London dispersion forces. Ni London dispersion forces. There is a force between the chlorine and chlorine atom. Or another example here is C2H6. Okay, so there is a London dispersion force between the carbon and hydrogen. This carbon, okay, these are carbon from the first molecule with the hydrogen from the second molecule. Okay, so this is the London dispersion force. Okay, London dispersion force only for the non-polar molecule. Okay, this is the second intermolecular forces, that is dipole-dipole forces. Nama pun dipole, so it means that this one for the polar molecule. Polar. Okay, so it means that there is an electron-rich region and there is an electron-poor region. So dipole-dipole forces is attractive forces between the positive end of the one polar molecule and the negative end for the another polar molecule. So it is between the polar molecules. For example, here interaction between the hydrochloric acid, hydrobromic acid, NF3 and CH3Cl. Okay, I give an example here, HCl. So Cl here, it is in electron rich region. So it should be the dipole is a negative dipole. It attract with the positive dipole of the another HCl. Kat sini satu molekul, kat sini lagi satu molekul. So molekul tu attract antara chlorine dengan hydrogen. Okay, chlorine yang molekul yang pertama dengan hydrogen molekul kedua. Attract dia mesti positif dengan negatif, bukannya negatif dengan negatif. Okay, there is an interaction between the negative form and positive yang sebelah sana. So this attraction here, we call it as dipole-dipole forces. Okay, this is the example. Okay, so this is the dipole forces between the Cl here and hydrogen here. Cl here and hydrogen here. Okay, dot-dot tu semuanya dipole forces. Ataupun kat sini for the SH2, okay, there is a dipole forces between the hydrogen here to this sulfur. Positive hydrogen and negative sulfur. From the positive hydrogen here and negative sulfur. This one for the SH2. And then CH3OH, methanol. Okay, there is an attraction between the oxygen with carbon. oxygen for the first molecule with the carbon for the second molecule, or hydrogen from the second molecule to the oxygen from the third molecule. Okay, so this is the dipole-diphosphosis. This one is dipole-diphosphosis. This one is hydrogen bonding. But both are intermolecular forces. Nanti kita tengok what is the hydrogen bonding. Okay. So the strength of intermolecular attraction increasing polarity. Dia menyebabkan polarity dia bertambah. So kalau tengok kat sini kan, yang dot-dot-dot ni semuanya adalah salah, yang merah tu, bukan dot-dot tu, merah tu adalah dipole forces. Kan, dipole forces. So merah tu semua dipole forces kan, negatif, positif. Positif, negatif. Positive, negative. Positive, negative. Positive, negative. Tu. So, the interaction between any two opposite charge is attractive. Solid red line. The interaction between any two like charge is repulsive. Dash-dash ni maksudnya dia tolak lah, sebab negatif dengan negatif kan dia tolak-tolak. Tapi antara yang merah ni, positif dengan negatif ni adalah bertambah. Dia tarik antara satu sama lain. Okay. Okay, this is last intermolecular forces, that is hydrogen bonding. So the hydrogen bonding is a special interaction between the hydrogen atom with a polar NH, OH and FH bond and electronegative oxygen, nitrogen and fluorine atom. Okay, hydrogen bonding. Hydrogen bonding nama pun hydrogen, kan? Ikatan dekat hydrogen. Tapi ikatan dekat hydrogen ni hanya untuk oksigen, nitrogen dengan fluorine atom sahaja. So, kalaulah hydrogen bond dengan carbon, kita tak kata dia hydrogen bonding. Hydrogen attract, bukan bond, attract dengan bromine, kita tak kata dia hydrogen bonding. So, hydrogen bonding ni wujud bila hydrogen attract ke oksigen, ataupun hydrogen attract ke nitrogen, ataupun hydrogen attract ke fluorine. Okay, so 3 atom ni saja kita panggil dia hydrogen atom. Okay, I give an example for the H2O. Okay, H2O, oxygen attract with hydrogen. So oxygen is a more electronegative, attract to the hydrogen that is more electropositive. So this bond we call it as hydrogen bond. Okay, hydrogen bond. And hydrogen bond only for example here, AH here, AH, NOOF, NOOF. So A and B here is NOOF sahaja. Okay. NOF in period table is here. In period 2 at group 5A, group 6A and group 7A. So hydrogen bonding only exists for this element only. Nitrogen, oxygen and fluorine. So for example, oxygen here will attract with the hydrogen. So this is hydrogen bonding. Nitrogen with the hydrogen. This one for the NH3. So this is NH3 first molecule and NH3 for the second molecule. So there is an interaction between nitrogen and hydrogen. Oxygen and hydrogen. OH2, H2O and NH3. So there is interaction between oxygen and hydrogen. Nitrogen and hydrogen from the NH3 and HF. HF boleh HF boleh. So H dengan nitrogen. NH3 dengan HF. So H dengan F. So OH2, H2O dengan NH3. So there is an interaction between hydrogen, nitrogen dengan hydrogen. So kalau tengok kat sini, perasan kat sini, molekul dia hanya oksigen dengan nitrogen dengan fluorine sahaja. So kalau elemen lain tak boleh. Dia tak membentuk hydrogen bonding. So the strength of intermolecular forces increase with an increase in molar mass or molecular size. So larger atom have larger electron cloud which are easier to polarize. So larger atom, it easier to polarize. It easier to become polar molecule. So molecular size and mass is generally parallel each other. So the dispersion force tend to increase in strength with increasing the molar weight as well. So kalau intermolecular forces tu bertambah, bila molecular weight tu bertambah. So macam ni, seperti inilah contohnya chlorine, chromium, bromine, iodine. So kalau tengok molecular weight dia bertambah kan, RMM dia bertambah. So intermolecular forces dia bertambah. So that's why dia perlukan tenaga yang tinggi, temperature yang tinggi untuk dia pecahkan ikatan. So that's why kita tengok boiling point dia tinggi sebab dia perlukan tenaga yang lebih untuk pecahkan ikatan dalam molekul tu. Antara molekul tu, hydrogen bonding tu. Bukan hydrogen bonding, intermolecular forces tu. Salah. Intermolecular forces. Okay, contoh lain, noble gas. Noble gas, from here you can see that molecular weight is increases. So, when the molecular weight increases, boiling point also increases. Why? Because this molecule need high energy to break the bond between the intermolecular forces. Okay, this graph show about the boiling point. Okay, versus period. Okay, so when high boiling point, it means that we need high energy to break the intermolecular forces. So from here, you can see that hydrogen bond is stronger than London dispersion forces. H2O, HF, and NH3. So it have a higher energy. It needs higher energy. So it is more stronger. But for the boiling point of the NH3, H2O, and HF are high compared to those the hydride of group 15, 16, and 17. Kalau kita akan bandingkan dia, dia adalah lagi tinggi. Okay, lagi tinggi. But when we compare between the H2O and HF, H2O has a boiling point higher than HF. Kenapa H2O lebih tinggi daripada HF? Okay, sebab each H2O atom is able to form 2 hydrogen bond. Nama pun H2O. Ada 2 hidrogen. So, kalau ada 2 hidrogen, maksudnya ada 2 hidrogen tu ada 2 lah untuk membentuk hydrogen bonding. Tapi bila kita compare dengan HF ni ada satu je, hidrogen dia satu saja kan, dengan nak membentuk hydrogen bonding dengan fluorine, dengan molekul satu lagi. Kalau kita ada 2 molekul HF. So, kalau saya ada HF kat sini. So, nak bentuk hydrogen bonding lagi dengan sebelah lagi. HF kat sini. So, ikatan dia kat mana? Dekat sini. Dekat sini. H dengan F. Okay. This is the hydrogen bonding between the fluorine and hydrogen. Fluorine and hydrogen. So, satu saja. Tapi kalau H2O, dia ada 2 H yang boleh membentuk hydrogen bonding. Okay, so this is about the strength of the intermolecular forces. Okay, that's all. Okay, habis sudah chapter 3. Okay, habis sudah chapter 3. Okay, now you need to answer all the question in tutorial for chapter 3. That's all. Thank you.